Okay, so this video, just so we're clear, is this video right here, 4.6 continued. You might think of it as 4.6c, and it is a continuation of log integration, so integration in that kind of situation. But I just want to start on this page first. Um, so we can understand the log helps us with a lot of rational functions. You saw that in the previous video. Um, it's helpful if you can see the integrand as the derivative of the other part. Derivative of the other part. So what am I saying? A function and its derivative. Now, in my class, and I hope that I continue this streak up, we have kind of played Kahoot with finding what the function is, what the derivative is, what u is. And I think that that hopefully helps you to understand. So think about when we played Kahoot, provided that we did, um, and use that. Find the function, okay? And it's not always as obvious. So if you see the next page, which is where our notes start today, you'll see that it can be a little tricky, okay? This right here is a problem because if you think about it, you have an x to the second power on the bottom and you have an x to the second power on the top. So do you see a function as derivative? No. You don't really because they're the same power. So what you need to do is you need to think of another way of rewriting this. Another way of writing this exact integrand, this, before you try anything. So what you're going to want to do is you're going to want to use long division. Okay? Anytime that your top is much too big or it doesn't seem right, you could always try long division to get a different form of an equation, and then hopefully it works out nice. So let's divide x squared plus x plus 1 by x squared plus 1. I'm not going to go really slow here. I'm going to assume you know your long division, and if you don't, you're going to have to work with me or just Google it and take a quick look at long division of polynomials. X squared into x squared one time. That gives us x squared plus 1 when we multiply this by this. Okay. Then we have to subtract these, so we're really adding the negative version of them. We have cancellation here, and we have x minus 1 because you can't combine those. Okay. You could bring down this plus 1, I guess, or you could just try to divide into it. I'm not like an amazing long divider, if you want to call it that. But it looks like what we're going to have here is a situation with a 1 over x. Because that 1 over x times the x squared, well, if we distribute that to that, so if we distribute this to these, we'd have x plus 1 over x, right? So we get a general form here. Now we want to subtract, right? So we're going to subtract this and subtract this. So we're going to have negative 1 minus 1 over x, and actually plus 1 is going to be here, and those are going to cancel out in a sense. And it looks like we have this remainder of, I guess, minus 1 over x, and you could put your remainder over your divisor, which would be, I guess, negative x to the negative 1 divided by x squared plus 1. Now I might have been able to divide this a little bit differently if I was a little stronger here, so I'm going to take just a moment to see if I could make this any better. I think algebraically everything's okay, but I don't love how that looks, and I think I might have been able to clean this up a little bit better if I was paying more attention. Okay, so after giving it a little bit of thought, I want to go back in time a little bit here. I want to talk about before this happened. So let's just go back to where we were here, I suppose. Okay, so here's where things were at, and we were just about to work on this next step. So I found another way. I mean, what I did wasn't wrong per se, but not as simple. So probably not the best route to go. So let me try to show you something that's a little cleaner. I apologize if you've already written this down. Well, at this point you have x, and then you can actually bring down this positive 1 and cancel it with this. You can kind of combine those two plus 0, I guess. So you really just have x, which is your remainder. And because that's not really dividing nicely by this, you can really just put your x remainder over your divisor, x squared plus 1. And this is equal to this when you divide it. So if you divide this, you'll get that by long division. Okay? So knowing when to stop on long division, maybe even I should brush up on that a little bit because I did it a way that wouldn't have been as nice. This will be a little bit better, and let's kind of keep going with this. So that means we've got the integral of 1 plus x over x squared plus 1 dx. And that's now what we're trying to work on. So let's just look at that integral for a minute and see if we can think about this for a minute. Well, the first thing I'm going to do is I'm simply going to integrate that, and that's going to be x. Okay? Now we haven't integrated this last part, so it's still going to be in the integral, so we have this here. But I have already integrated that first part. It's just done. So I immediately integrated that. Now I look and I say, okay, what's going on here in this integral? That's what I want to solve. And it looks like there's a function and a derivative. So here's the u, here's the du, right? We don't want that 2 there. This is something we should be comfortable with from the last video. So it looks like this is actually the integral of 1/2 du over u. That's how I like to write it. The x is still there. And now we have that integrates to 1/2 ln of u, sorry, that's 1/2, ln of the absolute value of u plus c. Now that would be our answer, however we got to simplify it. So our real answer is going to be x plus 1/2 ln of the absolute value of x squared plus 1. Now you might notice that the book might write some of these answers weirdly. They might actually take this exponent and throw it into there. They might have x ln of the square root of x squared plus 1. They're just using properties of exponents to make it what they think is simpler. I think it's more complicated. So we're happy with this answer, okay? But sometimes they're going to take this and put it up here as an exponent because of log properties. And then it'll become a 1/2 exponent, which is a square root. Okay, moving on. So this example, we could do it, we could not do it. Let me see where I'm at with my video. I guess I'll keep it on the err on the side of shorter. I'm just going to show you what I would do here. So this doesn't seem super obvious, but it does seem that u equals x plus 1 would help. We've done these kinds before, I think. Then du would equal dx. And we kind of be in good shape. We'd have the integral of u squared on the bottom. We'd have du here for the dx, and we'd have this 2x, and that'd really be the question. What do we do with that? Well, what you do is, we've kind of done a few of these, and I hope you're getting comfortable with it. You'd realize that x is equal to u minus 1, and you'd put 2u minus 2, because that's 2x, there. And then, because of that, you're going to have to break it into two fractions. You're going to have 2u over u squared minus 2 over u squared du. And you're going to have to integrate both of those. So I just kind of skimmed through that. If you think you need a little more time, spend some. But I think you might be okay with these at this point. So what I do want you to try is this one. It's a long division one. So you'll need to, oh, I kind of gave it away, sorry, but think about your long division, see how you're doing with it. It's number 19 on 351. So you're going to change the form of it because you have a squared and a fourth. If this was an x to the fifth, maybe it would work out nice, but you don't have a function and derivative really here. So you're going to need to change this whole layout, the whole way this is looking, I guess. And I might have assigned this already. It's possible, but at any rate, try this problem and see how you do. And I'm going to end this video here, and then there'll be one more for today's assignment, more than likely. But always what I say in class trumps what I say on the video, so keep that in mind. All right.